Hi everybody. Time for one more video. I'm going to try and show you guys how to work on section 3.4, which is about solving geometry applications. So I picked out a few problems and I thought I'd again work through them with you and see if they can help you out. So we're going to start with this You Try It 3.68. You're going to find that these applications involve some facts from geometry that you probably learned in high school and might not remember, so I think a little refresher as we go through is not a bad idea. But again, I'm going to be using my 5-step method. So again, this is 3.68, the You Try It problem. And so step 1 is always, what am I supposed to find? And so it says, if you read the second sentence, find the measure of the third angle. I'm going to write that down. And while I'm writing that down, recall that step 2 is going to be to define variables. And a lot of times the way I've been doing step 2 is I'll write let x equals something. But I'm telling you that for a geometry application, a lot of times it's good to draw a picture. And what the heck, I'm going to draw a triangle. I don't know if that's what the triangle looks like. I mean, triangles can look very different, but they all have 3 sides and 3 angles. It says the measures of 2 of the angles of a triangle are 49 degrees and 75 degrees. I'm going to call this one 49 degrees. I'm going to call this one 75 degrees. Oh, find the measure of the third angle. I don't know the third angle, so I'm going to put a little x degrees here. Okay, that's equivalent, of course, to saying let x equal the measure of the third angle, but I won't usually write that. I'll just do a little diagram and I'll know what it represents. So now step 3, I'm going to try and write an equation. And this is a fact from geometry that you need to know or else you can't do this problem. The sum of the 3 angles of any triangle is 180 degrees. You probably remember that. You learned that at some point. Okay, so we can turn that statement into an equation, and you're probably getting better at this now. You know that is, we usually translate as equals. You know that sum says we're going to add things together. Now we're adding 3 angles together. So I'm actually going to need a couple of plus signs here, right? I'm going to say that 75 plus 49 plus x is equal to 180. So there's my equation. Step 4, of course, is to solve the equation. So let's see, 75 and 49, that's 124, plus x is equal to 180. And so if I subtract 124 from both sides, I'll get what x equals. So that'd be 56. And I can now answer the question. Third angle is 56 degrees. So, that's a nice example for us. How about 3.70 next? Let's see what we're trying to find. How long is the third side? So I'll write that down. Step 1, find the length. Yeah, so last time we found the measure of the third angle. Now we're going to find the length of the third side. So step 2, I'm going to go ahead and draw a triangle again. What do they tell me this time? The lengths of 2 sides of a triangular window are 7 feet and 5 feet. Interesting. So maybe this is 7 and maybe this is 5 feet. The perimeter is 18 feet. Now, perimeter means distance around. Okay? So, in other words, if you took a tape measure and measured from here to here, it'd be 5 feet. And if you kept going from here to here, it'd be another 7 feet. And if you came all the way back like that, we don't know this side. We're supposed to find that, so I'm going to put an X there. Say that's X feet, right? So since the perimeter is the distance around, we can get an equation from this. They told me the perimeter is, it says 18 feet. So we can turn this into an equation, right? So remember, step 3 is to write the equation. I'm telling you that fact is going to give it to me. The fact that the perimeter is 18 feet, well, the distance around, I could say, is 5 plus 7 plus x is 18. And from here, I think it's pretty easy at this point. 12 plus x is 18. One step later, you'll get x is 6. I guess it went off the screen for you. But we can say the third side is 6 feet. And you know, it's funny because when I look at my picture, it looks like the third side's the longest side, but that wasn't the case. Pictures can be misleading. I mean, I didn't know what this triangular window looked like. I just drew a triangle. So we'll do a couple more, and then I think you should be good after that. 3.72. A triangular tent door has an area of 15 square feet. The height is 5 feet. What is the base? Okay, so this is 3.72. Step 1 says find the base. And sometimes students get confused between perimeter, which means distance around, and area, okay? Area is kind of like space, right? So, again, I'm going to draw a picture of a triangle, but when you have this triangle, maybe this is really a tent, right? So they say this is the door of the tent. Here's the tent. This is the door of the, you know, maybe you can get in through here. Well, you notice I drew a line from one vertex, one corner to the opposite side, such that it makes a right angle. If that happens, this is called the height. The height has to make a right angle with the opposite side. And then the opposite side, this is called a base. Okay? And if you're given those things, then there's a formula that can tell you what the area is. The area is 1/2 the area of the base, or the length of the base, times the height. Sometimes people write A equals 1/2 BH, which means the same thing. And you might wonder, where did that formula come from? Well, it came from the fact that if you were to reflect this image, or actually just kind of pivot it, you can draw another triangle the same size and shape up here, and you'd have a parallelogram. And as a matter of fact, you could even cut this piece off here and put it over here, and now you'd have a rectangle. And people know that the formula for the area of a rectangle is base times height. So it wouldn't surprise you then that since this rectangle is double the area of the triangle, that the area of the triangle is 1/2 base times height. Okay. So that's interesting, but let's go back to our problem. A triangular tent door has an area of 15 square feet. So again, I guess where I'm at now is I'm on step 3. I want to write an equation, and I guess what I know is the area equals 15. Sometimes square feet is written that way, feet with a little 2 up there, because it's feet times feet gives you square feet. And so what we know is we can write 1/2 the base times the height is equal to 15. Now, do we know the base or the height? I guess we don't know the base. We're trying to find that. I'm going to call it B. Do we know anything about the height? Oh yeah, they tell me. The height is 5 feet. So we can write that the height is 5 feet. So I can put a 5 here, and I can put a b here, and I have a 1/2. And so we're done with step 3. We've found an equation. And so step 4 is to try and solve the equation. Now, I'm going to multiply the half times 5. That's 5 halves times b is 15. And if you want to solve this in one step, you can multiply both sides by 2/5, because then the 2's cancel and the 5's cancel, and we have b by itself. Now you might say, well, what's going to cancel on the right? Well, there's a trick. You should write 15 as a fraction. How do you write a whole number as a fraction? You put it over 1, right? And now, does anything cancel? Well, sure. The 5 and the 15 cancel. I get a 1 here and I get a 3 here. 3 times 2 is 6, so we get 6 over 1, right? So the base is 6. 6 divided by 1 is 6. So 5, I could say, step 5, the base is 6 feet long. 6 feet long, 5 feet high. Interesting problem. Now, these last problems about right triangles, okay, 3.38 is a lot like one we just did. There's this theorem called the Pythagorean theorem. I ended up not assigning any of these, but I will do 3.78 and then call it quits. So they actually give me a picture here, okay? It's a right triangle, and what that means is that that angle there is 90 degrees. They tell me that this is a length of 5, maybe it's feet. They didn't actually tell me. This might be 12 feet. Maybe it's just inches, I don't know. And then they put a C here, and they say, can you figure out what C is? So it turns out that there's a famous theorem proven by a guy named Euclid called the Pythagorean theorem. It was also proven by President Garfield, whose house in Menor you guys should go see if you haven't seen it. He came up with his own proof of the Pythagorean theorem, but it's probably, yeah, it is. It's the most famous theorem in mathematics, which is something that people have proven. And what the theorem says is that if you have a triangle that has a 90-degree angle in it, a right angle, then this formula holds: a squared plus b squared equals c squared. And a, b, and c are the lengths of the sides, and the only thing you have to remember is that the c is the longest side, which will always be across from the biggest angle, the 90-degree angle. So this only works if you have a 90-degree angle. But if you know this fact, then you can say things like, well, we could put the side lengths in. It doesn't matter which the other ones are. I'll put the 12 here and the 5 here, and I know that this is c squared. 12 times 12 is 144, and 5 times 5 is 25, so this is c squared. So I know now that c squared is 169. I'd really like to know what c is. And so on my calculator, I have a button that can figure out what c is. It's called the square root button. So see, if I type in 169, and if I press this symbol, that gives me the square root. That tells me what times itself. So it turns out that if you work out 13, right, you could check that 13 times 13 ends up being 169. But it turns out that 13 would be the length of this side, according to the Pythagorean theorem. I didn't assign those because it's not much of a word problem. It's more of a formula problem, I would say. So, kind of left those out. But I hope this video will help you as you finish the homework for this section. Bye for now.